Hi class, this is the notes for Integrated Math 1, lesson 1.1 on arithmetic sequences. Today we're just going to look at creating a table, graph, and the recursive equation. All right, so here's our first sequence. We have the numbers 8, 12, and 16. So the first thing we want to do is figure out what n and a sub n represent. So n represents the term number, and a sub n represents the term value. So what that means is the term, if you look at the very first one, the term number is going to be 1 because 8 is the first term, 2 because 12 is the second term, 3 because 16 is the third term, and then the value would be what we put under the a sub n column. So if n is 1, our term value is 8. If n is 2, we get 12. If n is 3, we get 16. So that's kind of our first step here. Now the second step is to figure out what is our pattern. Now in an arithmetic sequence, our pattern is going to be adding or subtracting for each term. So if we look to go from 8 to 12, we would add 4, and as long as that pattern continues in the same amount, so we're adding the same value each time, then we have an arithmetic sequence. So this is what we call our common difference. And in other words, we use a D to stand for common difference, which would be D equals 4 in this case. And then we can use that pattern to continue and figure out the fourth term, fifth term, sixth term. We can keep going. So if I take 16 and I add 4 again, I'm going to get 20. And I don't need more than that right now, but I mean, if I wanted, I could get the fifth term, which would be 24. I could keep adding 4 each time to get the next term. I can also go backwards. So if my first term is 8, my 0 term, which sounds a little strange, but it'll make sense later. But my 0 term, if I subtract 4, 8 minus 4 is a positive 4. And then you can always double check that that plus 4 gets you back to 8. All right, so that's how we take our sequence and make a table. Now we're going to use that table, and for n, we're going to use the x values on our graph, and for a sub n, we're going to use the y values on our graph. So in other words, this is going to be our n and our a sub n. So if I start plotting these points, my first term was at 8, so that's going to be the point 1, 8. My second term is at 12, so I get the point 2, 12. 3, 16, 4, 20, 5, 24. And then if I go backwards, my 0 term would be 4. And as you can see, we get a really nice linear graph. So the points should line up, and we're going to look at this a little closer later, but one of the really cool things is that the slope of this line, if we look at the slope from one point to the other, it goes up 4 over 1. So our slope is up 4 over 1, which is 4, which is the same as our common difference. So kind of a cool connection we're going to use a lot later in this course. All right, so we already talked about what n and a sub n represents. If we look at what the pattern is, so if I ask you what is the pattern, you would simply say we add 4 to get to the next term. Hopefully you aren't struggling too much to read my handwriting. All right, if we look at that graph, again, those points go up at a constant rate of change. Using a constant slope is another way to think about that. It creates a nice linear graph, which is a straight line. The slope of the graph is 4, which is the same as our common difference. And now we get to the very last question here, which is what is the recursive formula or the recursive equation? So recursive equation means, it's an equation that gets you to the next term if you know the term before it. So if I write this out in words, the next term would equal the previous term plus 4. And if I do that in formatting, like using our formatting for what the term number and the term value are, if we think about the next term being a sub n, so the value of the next term, if our next term is a sub n, then our previous term would be a sub n minus 1. And that might be a little confusing, but if we go back up here, and if I think about, like, let me try to use a different color here. All right, if we look at, we'll use pink. If this term here is a sub 5, and that would be like the fifth term, then what I would do is I would take the previous term, the term right before it would be a sub 4, and I would add 4 to it. So a sub 5 would equal a sub 4 plus 4, because our common difference was 4. And if you notice, this number and this number are just one away from each other. So if this is n, or a sub n, then the 4 would be the n minus 1, so just the term right before it. So that is how we write our recursive equation using our sequencing notation of a sub n. All right, let's look at one more example. Let me go back to my blue here. All right, so here's one more example just to make sure we've got it. So again, the first thing I'm going to do is I'm going to think about my term number compared to the value. The first one is always term 1. And I like to start my tables off with a 0 so that I can go backwards, and later on that's going to connect when we do slope-intercept form, it's going to connect to the y-intercept of our graph, which is a really nice connection. So that's why I like including 0 in my tables. All right, so let's see. We've got, if n is 1, we start with 20. If n is 2, it's 15. If n is 3, we get 10. So now I have to figure out what is my pattern. Well, if you notice, I am going down this time, so I'm going to be subtracting 5. All right, so if I do 10 minus 5, I would get the number 5. And if I want to go backwards, I have to think about what minus 5 is 20, or you can think about adding 5. So the opposite of minus 5 is plus 5, and we get to 25 for my 0 term. So, but again, our common difference is always going forward in our sequence. So we wouldn't think about what we did going backwards. Our common difference would be a negative 5 this time because we are subtracting. All right, let's look at our graph. So my 0 term would be at 25. My first term is at 20, so I get the point 1, 20, the point 2, 15, the point 3, 10, the point 4, 5, and I could keep going. If I go one more, it's kind of nice because if I do 5 minus 5, I get 0, which is nice. We like seeing those intercepts if we can. All right, and then, I could keep going if I want. 0 minus 5 is a negative 5. So at 6, I'd be at negative 5, and then I definitely run off my graph. So I'm not going to do more than that. But as you can see, we have another linear function. Our slope is a negative value this time. And again, it does correspond to our common difference. So here I'd go down 5 over 1. And you can see that slope kind of continues, repeats the pattern. So negative 5 over 1, which is the same as negative 5, which is the same as our common difference. I love that connection. All right, and then let's see. So if I go down, what is the pattern? We subtract 5 to get to the next term. What is the shape? Again, it is linear with a slope of -5. What is the y-intercept? So we didn't ask this question last time, but it's kind of cool to look at. Our y-intercept is 25, which corresponds to our 0 term. So the y-intercept is 25, or the point 0, 25, if you want to write it as a coordinate point. Sorry, my 5 was a little sloppy there. Let's fix that. 5, which is also our value of our 0 term, or in other words, a sub 0. So lots of different ways to look at that. And then what is our recursive equation? So again, this is kind of the hardest part, I think, here for today's lesson. If we write it in words, our next term is what we get if we take the previous term and we subtract 5. In notation, a sub n would equal a sub n minus 1 minus 5. So again, that n and that n minus 1 just represents the term number. For example, if this here is a sub 6 and this is a sub 5, so to get a sub 6, I'm taking the previous term, the one right before it, so a sub 5, and I'm subtracting 5 because that's my common difference. All right, and I think that does it for lesson 1.1.